Hello everyone, welcome to another video. In this video we are going to see how we can do GitOps with ArgoCD. But before we go into practice, let's first understand what this GitOps mindset is in a nutshell. So with GitOps, you treat your repositories as a first-class citizen. This means, in the context of GitOps, that your repository is the source of truth for whatever is deployed on your target system, in this case, Kubernetes. Okay? This makes it easier for you to check in any given time what version of your application is deployed. Okay? And it makes it easier for you to manage yourself knowing what is actually on production. This is a bit of a change compared to what we used to do before. Before, you assume that whatever is on your application source code repository is whatever is deployed. But sometimes that's not true because you do rollbacks or you do whatever because some release is faulty, and you don't have this visibility. Okay, so you do this assumption that whatever is on your application source code is what is deployed in production. But with GitOps, you actually are certain of that, because whatever is deployed on production is on or centralized on GitHub or on your repository. Okay, you can do GitOps with GitLab. Doesn't necessarily have to be GitHub, but we are going to use GitHub in this case. Okay, so as a summary about what this GitOps is a way for you to check or to manage what is deployed in production and have your repository as the source of truth for whatever is deployed in production. And it makes it easier for you to control and get this information. Okay. So what are we going to achieve based on that in this video? So first we have a repository that contains our source code application. Okay. In our case, it will be a very simple Go web server that just does an hello world, nothing crazy. And whenever we merge to main, we traditionally run our CICD pipeline. Okay. And this happens regardless of the paradigm you choose. Normally, this is what you do. In our case, we are going to use GitHub Actions. Okay. So whenever we push to main on our application source code repository, ultimately what will come out of this CI/CD pipeline is two things. Okay. First, a Docker image. Okay, so this is the artifact we want to deploy. In our case, we are not going to use Docker Hub as our repository for images. We are going to use GitHub's container registry. Okay, and the second outcome of this CI/CD pipeline is going to be a commit message that we will apply on a separate repository. And this repository is what I told you is the source of truth for whatever is deployed on your target system. Okay, in this case, Kubernetes. Okay. In this paradigm, you know already that whatever is on this source of truth repository should be what is deployed on Kubernetes. Okay, you can track whatever is deployed on Kubernetes. Okay. So normally on our traditional pipeline or development system, we don't have this step here. Okay, the outcome of this CICD is normally a deployment right away to Kubernetes, okay? But with this GitOps mindset, you can have this separate repository. You can also not have it. I suggest to have it, just so that you don't mess up your application commits with CD commits. But this is the outcome of this CI/CD pipeline. Okay, you have a source of truth repository that has commits that should represent whatever should be deployed on production. And then on our Kubernetes cluster, we will have an agent, in this case ArgoCD, that every X minutes, I think is every 5 minutes or 3 minutes, will pull data from the GitOps repository, pretty much comparing what it has on the local cluster with whatever is on GitHub, on your repository, generically speaking. So let's assume that you run this on the first time. So version is 0, okay, you're bootstrapping the cluster. And then here on GitHub's repository, there's version 1. Your agent will see, okay, I have nothing applied on my cluster and I have version 1 on my repository. I will apply these changes to the cluster. Okay. Same again. So you do a new code change, you merge it to main. The CD runs, CICD runs, generates a commit on your GitHub repository, and then whenever the agent pulls from your repository, it checks, okay, there's a new version to be deployed. Let me deploy it. Okay. And so your agent, once it checks that it has new changes to deploy, it will apply those changes. Okay. Of course, in the case of ArgoCD, we can configure it not to apply and then have a manual intervention. But if you want to use this continuous delivery mindset that Argo has, so normally you should have this automatically. Okay, so when there's a change here, you should automatically apply it to the cluster. Okay, so having this picture or a high-level overview of what we want to achieve, let's now see what ArgoCD is, because we are going to use it as this agent on the cluster to pull data and apply the new changes on our cluster. Okay. So ArgoCD is actually a really cool product in my opinion, and they have here a very simple description of what it is. It's ArgoCD. It's a declarative. Okay, we will see this in practice when we write ArgoCD manifests. But ArgoCD likes to work with declarative paradigms. Okay, we use this, for example, with Kubernetes when we have our deployments and so on. GitOps continuous delivery tool for Kubernetes. Okay. In our case, with ArgoCD, we use Kubernetes. Okay. And as you can see from this animation here, but we will soon see this in practice, you see the status of whatever is deployed on Kubernetes, then you see that something is out of sync and you can manually apply it, and then you have the latest versions here of your the latest versions of your application applied on the cluster. Okay. So, but ArgoCD is just an agent to install. It does that management. That is what I have on my cluster, whatever is on my repository, and then it does the sync automatically or manually, as you can see here, if that's not the case. Okay. Of course, ArgoCD is super powerful. We're going just to explore a section of it, a subsection of it, but there's much more you can do with Argo than what we are going to see on this video specifically. Okay. So let's start now with our code. Okay, with our code. So as I told you before, we have the source code for our application, okay? And it's a simple Go server, okay, that just listens on 8080 and then returns an hello GitOps back. And it has a Docker file that packages this application, okay? It's not the focus of this video, so this is the starter code that we have, okay? Super simple application, okay? Now, the first step, as I told you, according to the diagram, is to, we have the application source code, and we want to generate this Docker image once we push to our main branch, right? And that's exactly what we are going to do now. We are going to configure this pipeline here, this GitHub Actions pipeline, to do precisely this. Okay. So according to GitHub Actions conventions, in order to create a GitHub Actions pipeline, you have to create a .github folder, and then inside of it have, and this now is our convention, workflows folder, and then here we can create our CICD pipeline. Okay, I will call it just CICD.yaml. Okay, and this is where we are going to put all of our code. Okay, for our CI/CD pipeline. Okay, so just some boilerplate code. Let's name this pipeline. Sorry, let's name this pipeline GitOps. Okay, and then the trigger. So on push to main. Okay, and then we need to specify what actions we are going to run. Okay, this autocomplete is going wild. And now we are going to specify the build steps. Okay. Okay. I was just going to have just one massive step called build and deploy. Runs on Ubuntu. Okay. And now we have the steps that we want to run. Now, before I go through the steps, this is just some simple boilerplate code of GitHub Actions. It's not the focus of this video, but pretty much we are creating a pipeline here. We name it GitOps. This is going to run whenever we push on main. Okay, this is the trigger that we are defining. And now here we could have more jobs. Now it depends on the personal flavor and personal taste. In our case here, we're just going to have one simple job called build, and this will build and generate the Docker image. Okay. So we could have split this more, but for simplicity's sake, let's just have this in one massive step. Okay. Or one job. Okay. Now, what are we going to do as a part of this step? Okay. What are the steps we said we want to do, or ultimately the goal we want to achieve? So first thing that we're going to do is to check out the application repository. So I need to check out my current application repository. Then based on that, what we will do is we will authenticate ourselves against the GitHub container registry, because as I told you, our goal is to generate a Docker image or an image and push it to a container registry, in this case GitHub's container registry, and we have to authenticate against that registry. So the second step we want to do is authenticate with GitHub container registry. Okay. The third step we want to do is to build and push the Docker image. Okay, so I already have my application code checked out. I already authenticated myself against the GitHub container registry. And now I can build and push this Docker image to that container registry. Okay. So once we do that, and coming back to this diagram, we have this part here done. Okay. So I checked out this. I build and push my Docker image to my container registry. Now I need to generate this commit message to this GitOps repository. Okay. And that's the step we are going to do. Okay, we are going to do it now. Okay. So coming back to what we were doing. So the fourth step would be to check out. You need to check out the GitOps repository. Okay. And as I told you, or as we know, we need to update the new image that we want to deploy. There are multiple ways you can do this update. Okay. Since on our GitOps repository, we are going to have our Kubernetes manifests that we want to update, and then that will be deployed. We need to update the YAML files that are going to be deployed. Okay, to trigger the fact that there is something new to update. And there are multiple ways you can do that. You can manually do YAML manipulation, or you can use a tool called Customize and have this done in an easier way. Okay. And that's what we're going to do. We are going to use Customize in order to update our Kubernetes manifests in an easier way. Okay. We're not going to actually update the manifest. We are going to do in a different way, but anyway, it's YAML manipulation, and Customize allows us to do that in an easier way. So the first, and you will see this will become much clearer on practice. Okay. So the fifth step will be to install Customize. So a tool called Customize. And then the sixth step will be to update the Customize file. So with Customize, you normally have a customization file, YAML file, next to your deployment or Kubernetes manifests, and a change on that file triggers ArgoCD to pretty much detect a change and update that change. Okay. And then once we do this, we need to actually generate the commit to the GitOps repository. Okay. Now, a step at a time. Now, so first, let's generate this step to check out the repository. Okay. Now, this is okay, let's call it checkout application repository. That's a good name. Uses actions v2. And we need to provide it something which is called with and with path app repo. Okay. The reason why we need to do this is, I don't know why this is going wild. Maybe it's indentation. Let me do it. It's indentation. So the reason why we are doing this with path is because on this pipeline we are going to check out two repositories. We are going to check out the application repository, and we are going to check out the GitOps repository. And by default, when you use this GitHub Actions checkout action, everything gets checked out into the root folder, the slash folder. And that can cause conflicts, and it's easier for us to specify, okay, you're going to check out this repository in the app repo folder, let's say. Okay. and that makes it easier for us to do this management. Okay. Now the other step that I told you we need to do is to authenticate against the so let's call it authenticate against this. Okay. And this I don't want to use this. And what we have to do is uses Docker login action. Okay, so this is the action that we are going to use. And we need to provide here to this action some configurations. Okay. To provide this configuration, we have to use again this with keyword. We specify the GitHub container registry, and we need to provide two things here. Okay, we need to provide a username, which normally represents the person that is doing this action. In this case, that I think will default to us. And then a password. Okay. Now we need to, and that's what I personally like to do. Sometimes this GitHub token, that there's a GitHub default token that you need to specify permissions and so on. So what I like to do is to generate a token, a GitHub token that I use for my GitHub actions that has permissions. We are going to create a token. We are going to call it, I don't know, GitOps _ token, something like this. Okay, we are going to manually generate this token in a second. Okay, but pretty much this token will allow us to authenticate against the container registry. Okay. Now the next thing we have to do, as specified here, is to build and push the Docker image. Okay. So we have guaranteed here that we are authenticated against our container registry. The next step we have to do is to actually do this build and push. Okay, so let's call this step build and push Docker image. And what we need to do is to use, no, not this, sorry, uses Docker build push action. And now we need to specify a couple of parameters. As you can see here, we need to specify where the application is stored. Okay. In this case, it's the app repo. We need to push it. And these are, now we are going to define the tags that we want to generate. Okay. So these are the tags we are going to generate. Okay. So first, I'll just put my name. If you use this, if you have your name with uppercase and lowercase, GitHub Actions will yell at you and say that this must be lowercase. So to avoid this issue, I'm putting my username lowercase. Okay. So because you need to specify a username for this, and your username, and if it has it has capital letters and lowercase letters, it will yell at the uppercase one. So might as well just put this here. And there's no pipe lowercase or to lowercase function as I'm aware of, and so we have to manually do this. Now we can call our application whatever we want. Let's call it Go Web Server. Okay. Let's generate a tag called latest. Okay. And we can generate another tag here called that uses the GitHub SHA commit message. Okay. A SHA from the commit message. I think that's the default. So this step here will push our Docker image into this repository with this name and these tags. Okay. So with just having these 3 steps here, so checking out the repository, authenticating against the GitHub container registry, and build and push the image. And by the way, on a normal CI pipeline, you would build the application, run tests, security scanning, blah, blah, blah. You can do much more steps. We are keeping it simple for now. But just by doing these 3 steps here, we are on this part of the pipeline here. Okay. We now just need to continue with the rest, with generating the commit message and then do all of this. Okay. So before we move on, let's create this GitOps token. Okay, this token will be very important for us going forward. Okay, so let me copy this name and let's generate a token with GitHub. Okay, so I'm going to my profile here. Okay, my GitHub profile, and then you can go to settings, and then you can go to developer settings and then generate. I'd like to generate a classic token. So I'll just generate a new one, new classic one. I'm gonna call it whatever, GitOps token. Okay. Yeah, you can leave it for 30 days. I'll delete it once I publish the video, but what do we need the scope of this token to be? Okay, I need access to repositories. We can put the packages, the lead packages, and maybe workflow. I don't think we need anything else from this long list. Okay, so let me generate this token. Okay. Now we have the token. We need to attach this token with the GitHub action one, because keep in mind that this is not that this is the value of this will be the token we created, but we need to bind the token we created with this secret so that it uses that value. This is a secret that will be used by the GitHub action itself. Now, how can we create secrets that the GitHub action itself will use? Well, we can go to the source code repository. So in this case, is this application source code one. You can go to settings. Not this one, but secrets and variables actions. Okay, secrets and variables actions. And you can create a repository secret. Okay. And now it's important that this secret must have the name of whatever you placed in your YAML manifest for the GitHub actions. Okay, we called it GitOps_token, so we must call this secret GitOps_token, and the value should be this one. Okay, so we copy paste the value, put it here, add secret. Okay, now when our pipeline runs, when our action runs, it will use this value. Okay, it will use this value. Okay, so that's out of the way. Now let's well, we can even do a small test just to see that things are actually deploying. So we can do a small check here. So let's add CI. So we're gonna just call it add CI. And when we push these to main, you should right away see that the application is running, or at least the GitHub action is running. Okay. So the action is pending, and now, assuming that this goes well and we don't have any issues, where can you find the repository, the NuGet repository? Oh no, sorry, not NuGet, Docker image repository. So if you go to your profile on GitHub, you should see this packages tab here, okay? And you can filter this by container, okay? You can also have other kinds of packages here, but if you filter by container, you can see the ones you have, okay? And as you can see, the action was successful because now we have a Go web server container here, or the image here, of course. Now, this is the name that, of course, we added here. Okay, so when we pushed here, we called it Go web server. If you call this potato, then this will be called potato. So anyway, now we can see that the container is being published into GitHub's container registry, okay? Now we have to do the other part of the pipeline, which is to, once I have a change, and by the way, we did not check something here. So here you have the latest tag, and you also have this SHA tag, which if you go here, it matches the 99 CAC8B 90i, so it matches the SHA from the commit message, okay? Now this is a shorter one, of course. Anyway, let's go back to our diagram, okay? And what we will do now, we will build this last part here until it commits to the GitHub source code, the GitOps repository, sorry, okay? So, so the first thing we have to do here is to again generate a name for our step, check out GitHub's repository, and since we are checking out a different repository that is not the one we is not the current one, so the one you're checking out, you need to specify which repository you are checking out. Okay, in this case, by default, we'll use the current one, but we want to check out a different repository. Now, in my example, I created a new one. I called it this thing here, and this is what I need to put on that part. Okay, this will be the source of truth for my GitOps action. Okay, so this part here. Okay, it will be the source of truth for whatever is deployed on Kubernetes. So I created this repository, and let me update this section here. Okay. Now, another thing we need, since this is another repository, we also need to specify the path. Okay, we can call this GitOps repo so that it gets checked out into a new folder, but we also need a token. Okay. And let me provide here this token. Okay. This token will be valid if you want to keep things private. Okay, if you want to keep things private, then you would need this token. If you want to keep things public, you don't need this token. But let's keep the token just in case you want something private. Okay. The next step is the customize one. Okay, you need to add customize to the pipeline. And now, so the name of this step is install customize. Sorry, install customize. Customize. I don't want this nasty thing here. And for this, we will actually use in an already existing action that allows us to do so, which is this one. This I don't know how to pronounce this, but you get the point. This is the action that allows you to set up the customize on the pipeline, and you can specify a version I'm going to use version, quite an old version, but I will use 3.6.1. Of course, there's probably more recent versions, but that's the one I'm going to use. If you want to use more recent versions, please check that out. But at least that's the one I'm comfortable with right now. And then next steps would be to actually do the changes that we want. Okay. But in order for us to do changes, we first need to have manifests in place to do changes, right? And that's what we are going to create with the with our Argo repository. Okay. So as I told you, we need to have the Kubernetes manifest. We need to have a couple other things. And so we can do this on this repository. So I'll create a folder called Go Web Server. This can be whatever name you want, by the way. And here I'll have my deployment, my Kubernetes deployment. Okay. I'll have here the Kubernetes service. And I'll also have here something that is useful for customize, which is the file called customization.yaml. Okay. So this customization file is a file that the customize tool looks by default when it wants to change something, okay, and perform this YAML replacement. Okay. So I'll just create. I already have one prepared, so we don't waste too much time for this deployment. So I have this Kubernetes deployment ready. It will listen in the 8080, as I showed you before, the source code. It listens on 8080, okay? And I already have a service prepared that will route requests on the port 8080 on the service to the 8080 on the container, okay? So it's two very simple things. Now, the only thing that is interesting here, and that's the thing you need to be aware of, is that on the image here, when I specify the Kubernetes deployment, on the image here, I placed a placeholder. Okay, this technically is not a valid Docker image, but I've placed here a placeholder, and this is the placeholder that Customize will in its customization folder will do the replacement, and then when Argo takes this from Customize, it will replace this here with whatever we have on the customization folder. Okay. I know it's a bit confusing, but we will see this in practice, and when we see it, it's going to be much clearer. But for now, have in consideration that whatever things you want to replace with Customize, you have to have a placeholder. Okay, we can call this whatever we want. Okay, so I just named it Go Server. Okay, and now comes the fun part. Okay, so I defined the placeholder that I want Customize to replace in the future. I want it to replace the newly created Docker image in my Kubernetes deployment. Okay, but I need to tell it to do this replacement. Okay. And for this, there's this customization YAML folder, or in this case file, sorry, that will allow you to define this replacement, okay? So the first thing we have to define is an API version, okay? In this case, it's this one. It's a customized config Kubernetes v1 beta 1. The kind is customization, okay? So this will be a customized, something used by Customize. then you need to specify the resources that this thing encompasses. In this case, I just put the deployment and the service. And now you need to define the things you want to change. Okay, in this case, the only thing I want to change is the image. The name that I placed it is Go server here. We can call this Go web server. Okay, so this placeholder here, I want to replace this placeholder with something new. Okay, this is so this thing here will be replaced. Okay, this will be replaced every time you build the image. Okay, so it will generate a new SHA and then it will replace this thing here. Okay, we can even put this. Okay, doesn't matter because this will be replaced. Now here is the thing we need to be careful about. Okay, what is the path on which Customize can find our Docker image? Okay, as I told you before, we created a Docker image that is stored in our GitHub container registry. So here on the new image name, we have to specify the location where we can find this Docker image. Okay. In this case, we just need to specify the .io, the container registry name of GitHub. Have to specify my username and the name we gave it. So we called it Go web server. Okay. Okay. So anyway, every time we use customize, it will go to this placeholder that is on our deployment. Okay. And it will replace this placeholder with this image name plus the tag that we created here. And this tag will be a tag that is generated when we do the commit. Okay, when we do the commit, we change and replace this tag with something else. The commit SHA, for example. Okay, now that we have these resources here that we can replace, now let's configure customize so that it actually triggers these changes. Okay. So here now we will tell customize, hey customize, please do that replacement. Okay. Because otherwise it does not know how to do that replacement. Okay. So here's how we do it then. So let me create a new step here. Update customization file. And we need to give it to this customization file the image registry where it should be running. Okay, so we need to create an environment variable here, env. And we need to tell it what is the image registry. Image registry. And in our case, it's this is the path for the image. And we also need to specify the tag. Okay, this is environment variables we are creating so that we can pass them to customize the work that we are going to run with customize. Okay, so we are going to use them here down below. Okay, so what actions do we have to do to in order to apply or run this customize command? Okay, first we need to go inside the checked out repository. Okay, we called it GitOps repo, right? So the first thing we have to do is to change directory to this. Okay. And inside of this, we will have a folder. What did we call it? We called it Go Web Server. Okay, so we need to cd inside the here inside the Go Web Server folder. Okay, and now inside of this inside of this folder, we need to run the customize commands. Okay. So in order to do so, I need to run the customize edit, set image, and I want the image name, the placeholder we gave it was Go Web Server, if I'm not mistaken, and replace it with this $ image reg and $. Wait, this is a bit clunky here, so something like this. Okay, so I'm going inside this folder and I'm running this customize command to change the image that has this placeholder to have now all of this changed. Okay, now we need to do the commit part. Okay, so we can go one directory back and now do the commit message. Now we need to define an user email and name for this. I have something prepared here. So for this matter, so here you can configure whatever you want. In this case, I'm using the default GitHub action information, but you can also specify here some bot you might have for your actions or your personal information, although I don't recommend. I just like to use the default. In order to configure Git, I like to use the default information from GitHub action. Okay. And now we just do git add dot, and we do a git commit -m, and we just write update image to tag whatever. Okay. Now this is the commit message that we will observe in the GitOps repository. Okay, keep in mind that all of these operations that we are performing are being performed inside the checked out repository. Okay, we checked it out here, the GitOps repo, and then we cd'd into it, and now we are doing all of these operations inside of it. Okay, so yeah, once this step is done, now you just need to push the changes. Okay, I mean, here we updated the file and generated commit message. Okay, and generate a commit. Now we can have this step to I can just right away do the git push here. Okay, I don't need this extra step here to actually do the commit and push. We can do it everything here and push. Okay, it's probably much easier to do so this way. Okay, so let's recap what we've done so far. Okay, so first or before I recap, let me run this and explain to you and watch this in practice. Okay, so add remaining CI steps. Okay, and before I commit this, I also need to commit the changes we've done for this. Okay, so add basic manifests for GitOps. Okay, we commit these changes, And we need to also commit the changes we've done to the application source code. So let's commit this, okay? So, and now if we go to this, to our repository, we should see that the CI will run now, okay? Now, what is our expectation, okay? Our expectation is, okay, so, and recapping the steps we've done so much, okay? First thing I do, I check out the current repository into because remember, this pipeline, this workflow is running on the application source code repository. Okay, so I check out the current repository. Okay, I know for a fact that I want to push these changes into a GitHub container registry, so I have to authenticate against that registry, and for that reason, I created a token, which will also be useful when we push the container itself. But we created a token that allows us to write packages, okay? And that token will also allow us to write commit messages as well. So we authenticated ourselves against the container registry, okay? Once that's done, I can build and push my Docker image to that container registry, okay? We saw this actually happening, okay? We saw the image going to the container registry, okay? So the image is in our, so let's go back to the diagram. So the image is now on the container registry, but we need to generate a commit message so that later on, Argo can look at it and apply the changes in the cluster, okay? And so that's what we configured next. We checked out the GitOps repository because this is the repository where we want to do the commit and we want to do the changes because that's the repository that Argo will be monitoring. And we checked out this repository in this folder. We installed the customize tool. Okay, we need to change the YAML files in a way or another. We can do YAML manipulation, or we can use a tool to help us. Customize is just one example. And then having customize installed, we will actually perform the change, okay? Because I generated an image with this tag, and I need to tell customize, hey, please replace this placeholder that I have with these values, okay? And then based on that, we just do a commit message, okay? Now let's see this, let's see if everything was successful. Okay, everything was successful. I should see a new image on the on our container registry with this starting SHA. So if I go here and I refresh, we see that the latest is this 72 EC7F, 72 EC7F. Okay. So it actually published this, but now if we go to this repository, we should see some changes. Okay. We now see the commit message that replaces the tag. I had made a mistake here on the registry, so it corrected my mistake. But you can see the point, okay? So GitHub, and if I go back here, I only have 3 commits messages, and one of them is generated by the actions user, okay? Okay, so it will be generated by this. It will be generated by the GitOps action, because when we configured it, we configured the commit to be done by this GitHub action user, okay? And so it's this GitHub action user, okay? It will generate this. This has the commit message that we created, so update image tag 2. So update image tag 2, and then the tag itself. which is the environment variable we created here. Okay. And so what it will do pretty much is to, every time you do a change on the application source code, it will ultimately change this value here. Okay. It will change this value, and then Argo will say, hey, I have a new value here. This value is different from the one I have locally. Let me do the update. Let me roll out this new update. Okay. So with all of these steps, we have successfully completed this part here, where we push things to GitHub, to our GitOps repo. This is going to be our source of truth. Okay. Now comes the other part, and the other part is to actually install and play around with ArgoCD. Okay. Now, first we need to have this Kubernetes cluster. Okay. You can use many tools to run Kubernetes locally. I personally use KIND, which stands for Kubernetes in Docker. You can also use Minikube, which is another valid alternative. And once you install KIND, you need to create a cluster locally with KIND, which you can see here some instructions on how to do so. But the command to create a cluster is called, in the case of KIND, it's KIND create cluster, and you give it a name. Name equals, I don't know, whatever. In my case, it was GitOps. Okay. So you run this command, and you should have a local cluster. Okay. So once you have this local cluster, you have to install Argo inside of it. Okay. And the way you can do it is by running these two commands here. Okay. So you can create a namespace for Argo, and you can apply these changes. Okay, so run pretty much this command. I've already done it. So if you go here and you go to kubectl get all ArgoCD, so ArgoCD namespace, you will see here that I have a bunch of things installed in this namespace. Okay. And pretty much this is what you should observe once you run that that command to install Argo locally. Okay. Now that you have Argo locally, one thing that you also need to install is the Argo CLI, because you need to have the password for. So if you go down below, it tells you to install the ArgoCD CLI. In my case, I'm using Windows. If you're using any Linux distribution, you can use whatever. Because you need to use this CLI to get the password for you to log in into Argo. Okay. In my case, since I'm using Windows, the command that I used was choco install ArgoCD -CLI. Okay. ArgoCD CLI. Okay. And this will install the ArgoCD CLI, and then once that's done, you should be able to do ArgoCD version. Okay. And this should tell you the version of ArgoCD. Okay. So once you install a local Kubernetes cluster or use your own in the cloud, and once you have ArgoCD installed in it, and the ArgoCD CLI in your local computer, now we are on a step where we can actually install. We already have Argo working, and we need to do these changes. Okay. Now, how can I access Argo? Okay. As you can see here, you need this password from Argo. So you copy this command, you go to your CLI, and you do this. Okay. And it returns the password that you should use to log in into Argo. But the question is, where is Argo? Okay. So for that, you can use a port forward. Okay. So you can run, for example, this port forward command that will allow you to locally access Argo on 8080. Okay. You can use any other ports. Okay. And if you run this, you should observe this message on the console. And if you go to localhost 8080, you should observe Argo deployed. Okay. Now the username is admin, and the password is the password that it was printed here on the console. So you copy this password, you go here, and voila. Okay, you should see Argo. Of course, I see some things here because I already played around with it yesterday. So let me just remove all of this nonsense and go server-app. Okay. But you should see here Argo, this Argo page. Okay, we will have a look at it now. Okay. So we installed Argo, we can access Argo, but there's this linking missing here. So, okay, I need to have a link between Argo and the source of truth repository that it should be my GitOps repository. Okay. Now, how can I do it? So Argo has this capability that allows you to create an application. So we click, you should see this new app. Okay. And now you can create your application. Okay. And that application is pretty much this link here. Okay. This link between Argo and that repository. Okay. So we can call our application Go Web Server. The project name can be default. The projects, they allow you to specify rules. For example, how which branches you're allowed to get data from. Okay. And for now, we have two policies that we can use, manually and automatic. Manual policy will, whenever there's a change, Argo will not automatically apply this change. It will let us know that something is off sync, and we have to manually trigger the change. Automatic will just automatically do the change. Okay. And we will test both of them. But let's start first with manual, and then when we do something else in a few minutes, we'll use the automatic approach. Okay. So let's select manual, and then we need the repository. Okay, where Argo will do the polling. In our case, this is the repo. Okay, so this is the GitOps source of truth repo that we want to use. Okay. And right away, and we specify just the head of the branch, but you can also specify other branches if they exist. And now it tells you, it gives you a hint of folders that you can scan, let's say. In our case, as you know, we created this Go Web Server folder that has our customization there. Okay. So we select this folder as the folder that we want to scan from. And now we need to, so Argo, as I told you, Argo, we configured this link here, okay? Now, it goes to this repository and gets data every X minutes. I think it's 5 or 3 by default. But now we need this link here. We need to, okay, I have new changes. So Argo has now knowledge that there is new changes, but he needs a target system to apply them to, okay? Because technically you can use Argo to manage other clusters, not just the cluster that Argo is installed on. But in our case, we have Argo in the cluster we are going to manage or apply the changes to. So in this case, we need to tell Argo, hey, please apply the changes in this cluster. And this is what we are configuring here. Okay, we are going to apply on this cluster, which is our local cluster. And we can give it a namespace. I'll just use default. It could be whatever namespace you want, but it's easier for us if it's this way. And I don't want to use anything else. So this is all we need to have a vanilla creation, okay? And I click create. And right away, you should see something like this here. And right away, you should see that it's, first of all, it's missing. And why is it missing? Because we have no records of this application ever existing in our cluster. So it says missing because it does not have anything to compare to, because this pretty much does not exist. Okay, and so it tells it's missing. And you can see here in the sync status that it says out of sync. So whatever is on my cluster is not what I have in now my source of truth. And you can even see here what we should have. Okay, this is the latest. There's this diff button that allows you to see what is different between what is on the cluster and what we expect. In this case, we expect everything to be there because there's nothing. Okay. And so what I will do, I will just click sync. Okay. Synchronize. And right away you should see that our changes are being propagated to our cluster. Okay. But this will not work. Okay, this will not work. And the reason why this will not work is because if you click here, it will tell you that it has an error trying to push for a new image. Okay, and why is that? So Argo is trying to pull this image for what it thinks is a public container registry of some kind. And of course this is private. So it's trying to get this image, but the image does not exist. At least it cannot see this private repository of ours. So we need to tell our Kubernetes deployment, we need to pass to our Kubernetes deployment an image pool secret. Okay, a secret that grants grants our deployment access to our private registry. Okay, and let's do that. So in our deployment, okay, we need to specify in our deployment an image pool secrets, okay? And we need to create this secret, okay? We need to create it on Kubernetes, okay? We can call this, I don't know, GitOps -secret, something like that, okay? Now, how do I create this secret in Kubernetes? Okay, there's actually a command you can run, okay? So kubectl create secret. It's going to be a Docker registry type, Docker registry, okay? And the name of our secret is GitOps dash secret. Okay. Now the Docker server, we need to specify a couple params to this. One of them is the Docker server we want to run. So in this case is GitHub container registry.io. We need to specify the Docker username. In this case would be your username. So this is my username. And we need to specify the password, Docker dash password. Okay. And this password will be the secret that we created before. Okay. Hopefully I still have it here. Yeah, this one. Okay. So this is going to be the password that you have here. Okay. And so when we create this secret, okay, now whenever we are going to grab this image, we are going to use this secret, okay? And this secret now has access to our private container registry. So let's just commit this, update deployment with image pool secret. Okay. Commit and push. Of course, we need still to grab the latest changes because this is the repository that keeps on getting updated every commit message. Okay. And so now if I go to this to our GitOps repository, I should see here my new change. Okay. So now I have this secret. Okay. Now let me sync it again. Hopefully it will now use my secret. Okay, and there you go. Okay, and now it's fixed. Now we have this. Now how can I access this? Of course, we are not using a normal Kubernetes cluster with ingress, so we have to do some work around locally. But before we go there, let me show you the manifest. Okay. Remember that on our, and let me go back to it. Here on our container, we specify that the image name is Go Web Server. But when you go to Argo, this image name is replaced by the username, the name of the image, and the tag. Okay, so effectively we are doing this replacement. Okay, so you don't see here this Go Web Server. Okay, if we come here, we don't see this Go Web Server. Okay, so we don't see it. We see it on the image name, of course, but not as a placeholder anymore. So effectively, there's this replacement happening. So the replacement is actually happening successfully. Okay. As I was telling you, how can you see effectively that this is working? Now we can again do a port forward. So in this case, we do a port forward. We use the Go Server service that we created. That service is listening on 8080. And then we are going to use locally the 910. Now we can use 920 just because. Okay. So ultimately, this kubectl forward command will route all requests that go to this Go service locally on 9020. It will route it to the Kubernetes service on 8080, and then this service will route everything that is on 8080 to the container port 8080. Okay, so effectively routing to the image itself, to the application that we are running. Okay, so This is a very common command we use with Kubernetes just to do some local testing or even some dev or QA testing, okay, in deployed clusters. Anyway, our Go application is now technically listening on 9020 locally. It's not actually the application, but the service. So if you go to localhost 9020, we should see this hello GitOps, okay? And effectively showing or showcasing that indeed locally we have this working, okay? Now I propose something, okay? Let's change our application and let's change from hello GitOps, which by the way is what we see here, from hello GitOps changed. Okay. Okay. So update application. Let's commit these changes. And now the entire workflow will run again. So as a reminder, we committed these changes here. Those changes are on main. Okay, they are on main. Main will run the CICD pipeline. At the end of such pipeline, there will be a new Docker image on our GitHub container registry. Then this pipeline will generate a commit message on our source of truth repository, in this case, the GitOps repository. Then ArgoCD on its next polling iteration will see that this is a new version and it will apply it to the cluster. Okay, should be automatically, but we made it manual so that we can see and test. Okay, so now let's see if so already generated the image should be 0445 045 blah 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 blah. We should observe a commit message here. Okay, this commit message is effectively telling us, hey, there's a new version, new tag. And if you go to Argo, Argo is telling you, hey, this is out of sync. Okay. Of course, I just saw it immediately. I was lucky because it did a refresh, but if you don't see it immediately, it's because it didn't pull yet. You can always click on a refresh, and refresh will go to the repository and see if that data is there. But keep in mind that even though it's out of sync, and now the application is healthy because it detects that there's something running, even though that it's out of sync, it did not do the changes because I told them, hey, I want this to be manual. And if I click sync and synchronize, this will create a new service, a new replica set, not a new service, but a new replica set, and create a new pod. Okay. Now let me close this one and do another port forward because I want the new changes. So if I go here and I go here and I click refresh, you see that we have the new changes here. Okay. So we actually fulfilled the entire end-to-end process. Okay. And whatever is on our GitOps source of truth repository is what is deployed on Kubernetes. Okay. So on Argo, I showed you how to create an app, and this is somehow bugged out, I don't know. And I showed you how to create an application manually, but that's not the way you should do it. You should strive to have your applications running always source coded, let's say. This is why you can, with ArgoCD, you can specify a YAML file where you can configure this application. Okay, so I'll delete this one. This is the one we manually created. Okay, server. Okay, and this one is still bugged out. Let me see if I can force delete it. Let me see if I refresh this app, if it goes away. No, anyway, we have to live with it. So let's go to our GitOps Argo repository, and let's do something else. Okay. So let me close this. So let's create the. So we created the application manually on the forum. Let's create it via a manifest file. So ArgoCD, creating a folder, you can name this whatever you want, and we can call this Go Web Server dash application.yaml. Okay, so this indeed will be the manifest file that we will apply on the cluster itself. Okay. So the API version that we have to use here is ArgoCD Approach v1 Alpha. The kind of the resource kind we want to create is application. Okay. We can give it some metadata. This is the name of the project we want to create. We can call it Go Web Server application, just to show you that this will come from this file. And the namespace where we want to apply this manifest is the ArgoCD namespace, which is the one that when you install ArgoCD on the cluster is installs by default. Now, project default. This is one thing we selected when we created it on the front end. Just as a reminder, you can create projects and then apply here, and these projects can have rules. But let's use the default one for now. First, we configured on the front end, if you remember, where we are going to read this from. So our source of truth repository. So there's this repo URL, and here we have to go back to our GitOps and just copy paste this. So this is where Argo will what happened here? Project spec project default. Okay. So this is where Argo will read from. We have target revision. We can put a specific branch. I'll just put head. And path, Go Web Server. Okay, it's this path I want. This is the path where my resources are actually being stored. So now you know where to read from, but you need to write to somewhere. So we need to specify the destination cluster. And as I told you before, this destination cluster will be the local cluster, but it can be some other cluster somewhere else. Okay. And the namespace we want is the default namespace for our application. Okay. So this is what we want. And now we also have a configuration we can apply, which is the sync policy. If you remember, we put it automated, manual, so that we manually would apply and sync if there was anything to sync. But ideally, you want this synchronization to be automated. You don't want to go manually click buttons. So here on the sync policy, we say, okay, I want an automated policy. And I have these two configurations. Prune just pretty much means delete everything from the cluster that is not referenced or tracked on GitHub or on Git. And self-heal just means that you can revert changes automatically if something deviates from whatever is on your source of truth. As an example, if someone manually applies or creates does a change on your pod or something like that, okay? So it manually changes this, manually puts your cluster into the desired state, and the desired state is whatever is on GitHub in this case. If there's something on the cluster that is not on the that is not on the on GitHub itself, the source of truth, then it will delete it. Okay, so this is what we need to do now. We need to apply this manifest into our cluster. So we can do kubectl apply -f ArgoCD go web server application. Okay, we apply this manifest. And if you go to Argo now, and if you refresh, oh, it's here. Okay, so this application is here. Okay. And I like this approach a bit better because you can source code your application. You can see what has changed over time or not. I think it's easier overall to have an S code policy. Okay, every X S code. Okay, in this case, your GitOps S code. So we have your application here, and now let's do a change on our code so that we can see it automatically applying here. Okay, so GitOps changed. Let's put here auto. Okay, and let's commit these changes. So change. I can just update application. Okay, and now the same flow again. And let me go here to this, and then I need to port forward to the service in a minute. So we just need to keep track of whatever is happening here so that we can see indeed that changes are being automatically applied on this. So once we have the new version, I will just click refresh. I don't want to wait for an entire refresh cycle from Argo. I want you guys to see that once I click refresh, which simulates every X minute polling, it will automatically apply the changes here on our cluster. Okay. So let's see. Okay, already has a new image. This image is 88.1. We already have the commit message that something has changed. It's now 88.1. And of course, we don't see anything here because Argo still didn't poll. But if I click refresh, you've seen that it's automatically applying the changes. And you can now see that the sync is enabled, and this is the last thing that is applied on this cluster. Okay, last sync. Okay, and if I go here to the deployment, I should see here the 88.1. So 88.1. Okay. Now, so this is cool. Okay, this is cool that you have all of this process automated. Okay, but there's something else that we can do. We can apply. If you're working on a big organization, you have lots of applications that you manage. In this case, we are in a simple scenario. We only have one application, but it can be that you have lots of applications, and seeing the status of them and managing them, it can be quite tricky. So there's a pattern that you normally see on Argo, which is called app of apps, which is the thing I just deleted, which is pretty much an application that references all the applications you have. And then you have a centralized place where you can see all the applications that exist. Okay. And how can I create this? Well, let's go to our GitOps, and I can create here an application. That's called app of apps application.yaml. Okay. And let me copy this boilerplate code just. And here the name can be app of all apps. I want this to be on the ArgoCD namespace because that's where Argo is running, so that's where all the files should be at. And I want this to be still on my repository, my GitOps repository. But instead of this Go Web Server path, which is my application, I want it to go to the ArgoCD path. This is where I have all of my applications, okay? And then it will do those linking, okay? And the rest I'll keep it as the same thing. So the only thing that has indeed changed was that now I'm pointing to an application folder, an ArgoCD application folder, and not our application itself. Okay. Now I can apply this command. Let me apply it here. kubectl apply -f ArgoCD app of all apps. And now what you should see. Oh, and we did not do something before. Wait a second. We did not check if the application was updated, but you can see that it was updated. I just didn't test it, but it was automatically updated. But you can see here on Argo that I have this app of all apps. And if I click on it, okay, there's an error here. And the issue is that we did not commit this yet. Okay, so what we need to do, we just need to commit this, of course. So add ArgoCD applications. Of course, we need first to, it will do a pull and push because we have new changes here. And once we commit these changes into our repository, now we should easily see. Let's synchronize this. Or let's refresh. And now you see that you can see all of the applications here, okay? So you can technically have this app of all apps outside of this and then see all of your applications here. But it's an easier way to, if you want to manage, you can go here, or if you want to see the Go web server application, you can click on it and go directly to some settings. But yeah, it's a way where you can visually have a centralized place. You can technically even sync if something is out of sync. Yeah, so this is a way with this app of all apps. It's a way that you can check, okay, I have things centralized. Now it's not opening for some reason, but you should see something like this, okay, where you can configure in a centralized place and so on, okay. And this is a pattern that I personally think is interesting if you have lots of applications. If you don't have much, so it probably does not matter at all. One thing that we can see here is that we haven't seen is rollbacks. Okay. So let's assume that something goes wrong here. Or how do you handle rollbacks? So if you do rollbacks, you can have a visual way of doing rollbacks. So you have this Israel rollback, and you can roll back to some change here. But the issue is that this will be out of sync. So if you refresh this is your application, and it automatically will sync with the 8081. Okay. So even if you do a rollback, I mean, it will always go back to the one you have on Argo. Okay. So if you come here, okay, and you see the latest one is 8081. So if you want, you can roll back to a specific version here. So we can go back to the 045 one, for example. Can roll back here, and it will automatically refresh. Okay, so if you had it manually, you could see here that you can you have an out of sync, but as you can see, this will always default to the 8081. Now, how do you handle rollbacks? Okay, you can do it on the front end if you have it manually, but the problem is that then you are on a scenario where whatever is on Git is not whatever is on Kubernetes. So the easiest way to handle rollbacks in with this GitOps is, of course, by reverting commits on the or doing changes, actual changes on the source of truth repository, so that this guy here knows that something is out of sync, and thus and propagates the changes. Okay, so rollbacks, don't do it via this user interface. Do it manually. Do it on the source of truth repository, and that will propagate it to this to the cluster. Okay. Also here on Argo, you have other things you can check. You can have different diagrams here. In this application, you see that traffic is flowing from the service to this pod and so on. You can see all of the manifests that are being managed by this application. So you can see a bunch of cool things here on the user interface. How many what is the GitOps control plane memory wise spending or consuming. But this is pretty much a really basic introduction to ArgoCD with GitOps, or GitOps with ArgoCD, and whatever the cool things you can do in an automated fashion. Okay. So yeah, hopefully you enjoyed the video. Thank you for watching, and I'll see you in the next one. Bye.